Hey guys, this is my latest project. It's going to be a propane fired forge for forging knives and just metal in general. So I'm just going to make a multi-part series going through how I'm going to build it, why I'm building it the way I am, and just some general fundamental reasons on the theory behind why I'm doing it this way. And I'm really building this forge on a budget. So I'll also talk about some upgrades that you can do if you want to, really get deeper and deeper into the hobby. But this will be a pretty cool project. If you want to follow each part of the video, just make sure you click the little subscribe button below, and if you click the bell next to it, you'll get a notification when a new video comes out. And be sure to check out some of my other videos, like the air ride suspension videos or homemade maple evapor videos. So here we go. We'll just kind of get into the parts that you need to buy if you want to do something like this. So the main elements of this, of course, are a burner of some sorts and your actual body of your forge. So I'll start with the burner. So of course, like I said, this will be a propane burner, and all this stuff for the most part can be bought at the hardware store or the Lowe's. But what I have as my kind of body or tube of my burner is a 3/4 inch by 8 inch piece of black pipe. For the end of it, I have a 4 inch by 1 inch piece of black pipe, and ideally these should almost slide into each other. The inside diameter of this is supposed to be 1.049, and the outside of this should be 1.050. And depending on which two pipes you match, you might get some that slide in and some that don't. I'm going to have to touch this one up a little bit with the grinder, but it's no big deal. For the end of this, I've got a cross T. It's a 3/4 inch threaded cross T. And I'll put a link to all this stuff on Amazon or wherever else I might find that you can get it, because sometimes you might not find things like this cross T in your local hardware store. So that'll thread onto the end here. I've got a 3/4 inch pipe cap for the end here, and this is a Venturi style burner. So you have forced air burners and you have Venturi burners, and this is by far the simpler of the two, but it's slightly less hot than the forced air, but just a lot less work. So a great thing for a starter or a budget build like this. To control my gas flow, I'm using a MIG welder tip. This is the Lincoln style. It has a 1/4 thread, so it's just a little bit easier for me to work with versus like a Hobart Miller style. I have a brass tube that this will thread into. Of course, I'll have to thread it, so you will need a 1/4 tap. And this is a thick-walled 5/16 brass tube. And I'll put a link for that because that was one of the harder things to find in the right wall thickness to tap it. This is a 3/8 inch flare male to female adapter, 3/8 inch flare on both sides. And this is a shutoff valve, a gas shutoff valve with a 3/8 inch flare fitting, which will just kind of be an emergency shutoff for me. And I can control the flow a little bit, but I'm not sure that I really will. And then this is really important here. So a normal grill gas regulator runs only about 1 psi. This particular regulator here is a 0 to 20 psi adjustable regulator, and you really do need that for an application like this. You need a lot more pressure than what a standard grill regulator will give you. If you really want to spend a little bit more, you can get the 0 to 30 psi, but this one's like $12, $13. The 0 to 30 is about $30. So like I said, this is definitely a budget build, and I want to try to keep everything within reason as much as possible. And those are really all you need to build the burner. The stuff I have going on at the end here, there's a few different ways you can approach it, but this is how I'm doing it. The reason I have side holes that'll be open is you need an air inlet to mix with your gas, and it uses a Venturi effect to kind of suck that air in and mix it with the gas. So if need be, I can put something like a washer on these to use as a choke. So let's see, I'll grab a washer. Yeah, so I could put a washer like this to use as a choke with a little screw. I hope to not need to do that, and the other thing I can also do is file this out larger if I need to. So I'm hoping not to need to do that, but I do have that reserved if I need to. Next thing is, of course, the body of the forge. This is just a small air tank from the air ride project that I have going on, and this is a scrap tank. This tank I'll actually be shortening to about 12 inches long, and I'm doing that for this project because I really just want to run one burner. I want it to be kind of propane efficient, and I don't really intend on doing anything long enough to really need the full 24 inches of this tank. One rule of thumb is per burner, you really can only heat about 300 cubic inches of area. So by shortening it to about 12 inches, that'll give me 285-ish cubic inches, so it's perfect for a single burner system. To insulate the inside of this tank, I have 1 inch thick ceramic insulation. This is also known as KO wool. And I'm going to put just a 1 inch thick layer. A lot of guys will use a 2 inch thick, but because this tank is only 8 inches in diameter, I'm only going to use 1 inch. And that'll give me about a 5.5 inch hole by the time I skin it on the inside, which is perfect. Just enough space to work on things, but not so big that it's hard to keep it hot. I'm using a fire brick on the bottom as the hard shelf for the metal to sit on, and I'm just using a standard fire brick. But if you wanted to do it even better, you could get a fire brick with a high alumina content, so 36% or more alumina, and that'll last a lot longer. And if you want to even do it one step better yet, you can get a kiln shelf, and that'll help reflect the heat a lot better. So if you're just kind of playing around with it, a fire brick should be fine, but as you move on, consider upgrading to different types of brick, or if your fire brick just gets chipped up in general. I'll skin the inside of the ceramic insulation with refractory cement, and I got high temp refractory cement, which is good for about 3,000 degrees Fahrenheit. The inside of this probably will reach like low 2000s at max, so it should last a little while, quite a while. And if you want to take it one step further, you can get a reflective material to even skin that with. And there's something called ITC 100, and that's what a lot of guys use as their reflective material. So if you plan on welding metal, that's definitely something you're going to want to do, but it's a whole lot more expensive. It's about $80 per small cup of it. So maybe just make sure you want to stick with the hobby first before you go into getting that. That's really all the main materials that you need to do this project. You're going to need some basic tools, and I'm not going to go through everything, and I'm going to try to do this without using too radical of tools. But you're going to need something to cut with, like a cut-off wheel on a grinder, the taps, drills, things like that. I am going to use a couple 1/4 20 screws here and there, so just some general hardware, so don't be surprised if you have to make a trip to the hardware store or borrow a tool or something off of a buddy. But in general, that's really what you need to do this project, and stay tuned and we'll have a video on how to actually build your burner. Thanks for watching.